Hello, my fellow mathletes, and welcome back to the 2007 Fermat paper from the University of Waterloo. We're up to question number 13 now. In the diagram, each of the numbers 0, 1, 2, all the way up to 7 here is used to label a vertex of the cube. Okay, well, we've got 8 numbers here, 8 vertices, that's fine. The numbers 0, 2, and 3 are placed down here as shown, 0, 3, and 2. The sum of the numbers at the ends of each edge must be a prime number. Note, 1 is not a prime number. Yeah, I've had many an argument with my public school math teachers about that. But it's true, 1 is not a prime number. Easiest way to see that, a common definition of a prime number is a number whose only factors are 1 and itself. The and implies that the other number is not 1, that it's a different number. Otherwise, we'd just say 1. You know, you don't say 1 and 1. You don't say my brothers are Jeff and Jeff. You just say my brother's Jeff. Okay? You know, if you go on to further math, you'll understand things like unique factorization. That's why we tend not to consider 1 a prime. You take some ring theory, you learn about units, but that's getting ahead of ourselves. The point is, 1 is not a prime number, and this needs to be stated because people really need to stop thinking it is. Okay. But the sum of the numbers of each end of an edge must be a prime number. Let's take this edge right here. 0 plus 3, hey, that's 3. 3 plus 2, hey, that's 5. All right, so I'm starting to understand what they're talking about. The value of M, N, P, and Q is, or must be. Okay, so I noticed that they're just asking me to add up the top. And I already know 0, 2, and 3 are out of the lineup. If I could just figure out what R is, you know, maybe R is 6, then I just add up 1, 4, 5, 7. I don't care where they're placed on the top. I don't have to figure out what N is to know what the sum of the top 4 numbers are. I just need to figure out what R is. That shouldn't be that bad. I mean, R plus 0 has to be a prime, and 2 is already taken, so R can't be an even number. All right, so let's go to our notepad here. So all eyes are on R. What could R be? So 0, 1, 2, 3, 4, 5, 6, and 7. And we know 0, 2, and 3 are already taken. What could R be? Well, could R be 1? No, because 0 plus 1 would need to be prime, and we'd already talked about this. 1 isn't a prime. Okay, so 1's definitely fine. Could it be 4? Well, 0 plus 4 would have to be a prime, and 4 isn't a prime, so no. Same with 6. But 5 and 7, those are possibilities, so now let's consider the 2 over here. R plus 2 has to be prime. So could R be 5? 5 plus 2 is 7. Bingo. How about if R is 7? That's our other possibility. 7 plus 2 is 9. Uh-oh, R is not 7. So R is 5. Okay. So R is 5. 5's off the list. So the numbers at the top, and I don't care where they're placed right now, are 1, 4, 6, and 7. So 1 plus 4 plus 6 plus 7, well, those two are 10, and those two are 8, so we've got a total of 18. So 18 is going to be our final answer here. And, I was looking at 14 for a second. So that's an answer of C. Now we've got time, because I'm not actually writing a contest here. We can figure out what these other numbers are. Hopefully this can be done. So we've got 5 down here. Let's just talk our way through this. So if 5's here, what other number can be placed with 0? Well, 0 plus whatever's up here has got to be prime. The only prime left is 7. So 7's got to go here. Okay. All right. So what else can we see? Well, here's 2. Could any even number go with 2? No. Because 2 plus another even number is yet another even number, and the only even prime is 2. So this has kind of got to be 1. So now the question is, where do 4 and 6 go? Okay? And it's just sort of matching, you know. Can 6 go here? Well, 7 plus 6 is 13. That's prime. 1 plus 6. is 7. That's prime. 6 plus 3 is 9. So 6 is out. 6 can't go here. The only thing that's left is 4. Does that work? 1 and 4 is 5. 7 and 4 is 11. And 3 and 4 is 7. We put 6 over here. 6 and 5 is 11. 6 and 7 is 13. 6 and 1 is 7. It's kind of nifty that the first 8 numbers can do that. That's pretty cool. We finished the whole thing. We didn't have to. We got our answer of 18 a while ago. But, sometimes when the contest is over, we take a look at these questions and say, well, I knew the short way to get my answer, but can I really finish this whole thing? Can I really finish the whole magic square that they gave me, rather than just get the value in this one corner that they asked about? Okay, just fun curiosities, and we finished up the question in style. So I will see you guys for the next question on the Fermat paper. I think it's question 14 in the next video. Until then, have a wonderful day.